Alright guys, we're back. I've got the 2A superposition, the 2A mesh, the 2B mesh, and now I'm going to do the 2B superposition, and then we will be all done with these problems. I hope that this helps you a lot because it's taken quite some time with all the technical difficulties and crap that I've had to deal with. That's okay. Let me rewrite the voltages that I got from Spice so that we know what we're looking for. VB2 should be 0.77 volts and VB1 should be 2 volts. So those are my voltages that I want to confirm that I get when I do this. And I'm going to go ahead and split the page again so that I can show my work pretty clearly. Split it right down the middle. And then up here I'm going to write 2B superposition. Again, I'm going to scan these notes. And then again up here I like to write it out, so let's write VB1 is going to be VB1 from part 1 plus VB1 from part 2. Leave some space. VB2 is going to be VB2 from part 1 plus VB2 from part 2. And VB3 is going to be VB3 from part 1 plus VB3 from part 2. Leave myself some space for that. And now let's move on to the actual solving. So I'll go part 1. I guess part 1 with no... This one's actually probably more difficult with no voltage source, so I'll do the no current source first. It's much easier when there's no current source. And then part 2 will be no voltage source. Alright, so let's move this up a little, give myself some space, and let's go right after it. So when I have no current source, this becomes pretty simple actually. Right, the current source is gone, so this whole top part is open. So I've got a resistor there, a resistor there, a resistor here, just a simple old voltage source right here. And then this is ground, right? Oh, I forgot a resistor. I'm not redrawing it, so let me just, there we go. Looks good. This is 5K and 3K, and this is 2K, 1K, 2 volts, and then let me label my nodes. This is VB3 from part 1. This is VB2 from part 1. And this is VB1 from part 1. Alright? So right off the bat, again, VB3 from part 1 is 2 volts, right? It's just a battery connected to ground, right? The minus terminal is connected to ground, so the plus terminal is 2 volts. So we know that. Now, what I can do here is, I think a lot of people might have gotten confused about these little branches of wire, but they may as well not be there, right? Nothing's happening. It's just some wire hanging off the end of some node. No current's going to flow through it. There's nothing connected to it, so we can kind of just disregard it. So what I guess I would do is I would combine the 5K and the 3K in series, right? And that would give me something that looks like this, an 8K, a 2K, and a 1K with my voltage source. 8K, 2K, 1K. And now this right here will be VB2-1, and this right here will be VB3-1. But note that VB1-1, the node between the 3K and the 5K, has gone away. So we need to keep that in mind. It's gone away. It's inside this 8K. Okay? 8K and 2K, right? 8K and 2K in parallel. That's whatever, I think it's 1.6K. Yeah, it is 1.6K, so I'm not even going to do it. So now this circuit could be redrawn as a 1.6K with a 1K. This is 1.6. And now this is just a voltage divider where this voltage here is 2 volts times 1.6K over 2.6K. And that voltage right there is the difference. It's the node in between the 1K and the 8K and 2K in parallel. So that is VB21, right? And so that's equal to whatever 2 times 1.6 over 2.6 is. 2 times 1.6 over 2.6 gives me 1.23 volts. Alright? And so now I've got that voltage, right? I said it's 1.23 volts, so I can come back over here. And then 5K and the 3K is just the voltage divider from that voltage. So I can say that VB11 is equal to 1.23 volts times 3K over 8K. So let's multiply this by 3 and then divide by 8. And I get 0.46 volts. Alright? So I got VB11, I got VB31, and I got VB21. Let me write those down. VB11 is 0.46 volts. Alright? VB2 from part 1 is 1.23 volts. And then VB3 from part 1 is 2 volts. Alright, so that's part 1, and now part 2 is definitely where it gets a little dicey, and that's because getting rid of this voltage source just makes the circuit incredibly ugly. So let's go ahead and do that. See something real quick, yeah. Alright, so if I get rid of the voltage source, what I end up with is a circuit that looks like this. You get a current source, got a resistor, I got a resistor here, got a resistor here, and then I've got nothing over here. So this is my new circuit, and this is ground, right? So this is 2K, 1K, 5K, 3K, 2 milliamps, and then what I've got is I've got this voltage right here is VB3 from part 2. This is VB2 from part 2, and this is VB1 from part 2. Alright, so I want to find those voltages. Actually, you know what? I think like I did last time, I'm going to write these out first. So we found the first part voltages, so VB11 was 0.46. VB21 was 1.23 volts. And VB31 was 2 volts. So it's going to be plus something, and plus something. We don't know what yet because we haven't solved for the second part. And then we'll go ahead and separate these. Alright, so now the first thing you may notice is that the 2K and the 1K are in parallel, right? They're in parallel between VB2 and ground. But you may also notice that VB32 is ground. Okay? And that's important because that means VB32 is 0 volts. But that actually makes sense because check this out. If I plug in 0 volts for VB32, that means VB3 is just going to be 2 volts, right? And that's correct because from our initial, analysis, VB3 should be 2 volts, and it is. So we already know that this is correct. So that is 0 volts. Alright? So we basically just need to find these two voltages to finish up the problem. Well, what we have to notice is that the 2K and the 1K are in parallel, so this circuit can be redrawn like so. Basically 2K and 1K in parallel again is going to give me, here, let me write 5K, and then I'll draw the 3K, and then 2K and 1K in parallel between VB2 and ground. That's going to be 0.667K. Alright? And this is ground right here. So this circuit looks really strange, right? Okay. So basically, the way that I went about solving this, and you could solve it a couple of ways, but the way that I went about solving it is I went and I drew a loop here, I drew a loop here, and I called this my I1 and I called this my I2. Okay, where I1 is 2 milliamps, right? And then I can go ahead and make a loop equation for I2, and I'm going to do that now. So that equation would be basically, let me draw my pluses and minuses in there just so that I have them for consistency. And now going this way, I go plus minus, plus minus. So when I go up across this 3K, I go minus I2 times 3K. I didn't mean to write this in red, but I guess it doesn't matter. And now when I go across the 5K, I've got I2 flowing, but I've also got I1 flowing. So it's going to be I2 minus 2 milliamps times 5K. And then I can go minus, again, I2 minus 2 milliamps times 0.667K. And that whole thing is equal to 0. I ran out of room, but just know that it's equal to 0. I'll clean it up. Let me write it again. Minus I2 times 3K. And then I've got to... Let me just group these two like terms, because those two are in series. So I can say minus I2 minus 2 milliamps. Instead of 5K and 0.667K, I can just say 5.667K. Right? Because they're in series. And then that whole thing is equal to 0. And now I have an equation that's just in terms of I2. So I can go ahead and I can find I2. Alright? Note also that this is VB32, this is VB1, 2, and then this node right here in the middle of the two resistors, that node is VB2, 2. Okay? So here, I can go ahead and I can say minus I2 times 3K, I can say minus I2 times 5.667K, and then plus, I think, a 2 times 5.667 gives me 11.33 volts equals 0. So this is minus I2 times 8.667K equals negative 11.33 volts. And now I divide by negative 8.667K on both sides. My negatives go away and I get 11.33 divided by 8.667, 1.31 milliamps is I2. Alright? So now I found I2. I know I1, so I can go ahead and find some of these voltages. Alright? So I know I2 is flowing up, right? Right here. So I'm dropping from 0 volts, and I'm dropping by, let's go plus minus, 1.31 times 3K, right? So that's going to give me 3.93. So I'm dropping by 3.93 volts. So then VB12 is negative 3.93 volts. Okay? So now the last voltage I need to find is this I1, or sorry, this VB22. And that's going to be equal to, basically, I know VB32 is 0. This is 0 volts, right? So I just need to find the drop across this 0.667K. So that voltage is going to be 0.667K multiplied by the current that's flowing through that resistor. Well, the current that's flowing through that resistor is I have 2 milliamps going this way, and I have 1.31 milliamps going this way. So the total current is going to be 2 minus 1.31, or 0.69 milliamps. Flowing this way, and so I'm dropping from 0 to some other negative voltage. Okay, and I'm basically dropping by 0.69 times 0.667K. That gives me a drop of 0.46 volts. All right. So I'm going from 0. I'm dropping by 0.46. Sorry, I'm just saying all this. Let me draw it over here because I'm really running out of room on there. So I basically have 0 volts here. I've got a current flowing this way of 0.69 milliamps, and that was derived from the 2 milliamps minus the 1.31 milliamps. Okay. And so that voltage drop across that, if I do that math, the 0.69 milliamps times the 0.667K came out to be 0.46 volts, which makes this voltage here a negative 0.46 volts, which is VB22. Alright, so I've got all my voltages. They're all over the place. It's challenging, guys, and this is not an easy problem. This part of the problem particularly is difficult. But let me just write out my voltages now. I got VB1 from part 2. What is that? Where is that? It's negative 3.93 volts. VB2 from part 2 I just found to be negative 0.46, and VB3 from part 2 we already knew was 0. Alright, so those are all my voltages. And so if I plug those in up here, this is a negative 3.93 volts. And if I take negative 3.93, 0.46 minus 3.93, I get negative 3.47, which is very close to what Spice got, so that's good. Negative 3.47 volts. Right, we already know this one's right, and so then the last one I need to check is VB2. I know that it's negative 0.46. So 1.23 minus 0.46, and I get 0.77, which is exactly what Spice got. Alright guys, so this was definitely a challenging problem. All of these were challenging. I hope that you learned something from these problems, and that you study problems like this, if not these exact problems, and make sure you can solve them on your own. Because if you can solve these problems, you will have absolutely no problem on the midterm. I hope that everybody has a great weekend, and I'll see everybody Monday.